Are you a coder who gets rejected based on no practical experience or because others have a strong LinkedIn personal brand and you don't? Your coaching institute will hate me for doing this, but I welcome you to Code to Career 30 days challenge where I have chosen these 5 total strangers out of my LinkedIn contacts and have taken up the challenge to help them go from jobless or underpaid to well paid job, that too without additional degrees and certifications in the next 30 days. If you are a coder and wants to get a well paid job, this is your golden chance to experience real project implementation from scratch that gets you a well paid job and builds your LinkedIn personal brand and also resume for absolutely free. So why just watch? Get into our WhatsApp community to experience this. Link is in the description. Now let's get started. Great. So welcome to the 7th session of Code to Career. We are just 2 weeks away from the conclusion. So 12 sessions, 4 weeks, four weeks, every day, every week, 3 sessions, which means 12 plus 1 we will have. And you might have already seen the message in the bigger group where we are going to have a bonus session next week. Sorry, not next week, coming Saturday. Yeah, I understood that you are curious to know about GitHub and the profile, whose profile I have shown. I actually asked her, and she is more than happy to share her experience with GitHub and how her career changed using the GitHub in an extensive way. Yeah. Let us start with questions. Any questions from the previous sessions? Any session? Any questions? What should I understand from the silence? That everything is clear or half-baked? I don't want to ask Vamsi, like if I ask, people will think that, oh, this fellow doesn't even know that thing. No questions?
One question. So the code, not today's code, yesterday's code 7.1 was there, right?
Your voice is a bit low, Harsha.
Now, now can you hear me?
I can
Hello?
hear you, but it is very low. Is your mouthpiece away from your mouth?
Oh, I'll disconnect and connect again.
Okay. Any other question from any one of you? Chiranjeev, Leela Prasad, Swaminathan, Anand, Chandrika, Snehal. If you remember, at the top, we have the TFTP packet where per transaction, the TIDs are being exchanged. And we understood that the low-level protocol, which is the transport protocol, and unreliable datagram, which is the UDP, will take the TIDs as port numbers and a session will be intact, right? How do you use TFTP packet structure, but remove UDP, still able to use the TIDs of source as well as destination or client and server and simulate something similar to UDP? This is the beginning thought process when you want to port your TFTP protocol to an RTOS or in bare metal. If you understand the TFTP protocol code, if you implement in a way that forget about the socket, there is an application which has certain amount of data that you put it into a TFTP packet, no socket or nothing, and you know that I have a client address, let us say I2C. Then you want to send it. possible? How many of you can imagine that scenario? How many of you can imagine that scenario, and how many of you feel that it is possible? Yeah, it's possible. Like, yeah, I want to understand if people are able to get a picture that there is no socket, there is nothing. I just have certain data, and I have the contents being packed into TFTP packet, and I don't have UDP. So the top portion is very simple. There is certain file, and you are doing some file operation, and you are sending it. No socket or nothing, no endpoints. The low level protocol or your transport protocol can be an I2C, and here is an opportunity for you to create a higher structure similar to UDP, directly calling your device driver code of send and receive. You can actually use the driver call if you have a driver like a I2C driver or UART driver, and actually you can send the TFTP packet itself. But let us say you want to have separate session kind of thing, or to understand that, okay, this is the communication I am doing with this particular client. This is the communication I am doing with this particular client, which is clearly identified using the TIDs. So you can have a random generator at your side, and there can be a random generator at the other side, which will generate the TIDs. Whenever a packet comes, you look at the packet and say that, okay, is it from X or Y or A or B or C? For that, you don't need to have elaborate code. It's just a if check, which is a TID. So the point I'm trying to make is a standalone TFTP code that you develop, you can write now actually with the read request and today's code where there is write request. If you take the packet formatting of the buffer, 512 bytes or what, 512 bytes or whatever, 513, 516, some macros are there, right? And you can actually run it if you have STM32 by creating a project using the HAL infrastructure, I2C or SPI or UART, and you can actually send it and see it on the console. How many of you get what I'm trying to say? You don't have to wait till the proper so-called TFTP is completely done. You can do that incremental thing. And this is also an opportunity where before doing that, you can write your test cases and see that, am I solving all the problems? Then in the code, you map the test case that you executed with that piece of code. Are you getting what I'm trying to say? I want you to live through the process, not just drag yourself and very passively absorb this content, but create that essay, go through it multiple number of times, map it to the diagrams and all those things, use cases and everything, create the CRC thing, and improve the code that is being given to you, and say that, okay, I would like to put all the entries or all the details that I want to have for my server into a structure. Create a identity for the structure or a persona for a structure. Go and write the test cases and map to the code that is being given to you, and improve the code. If you want to work with me personally, where I guarantee to work with you until you secure a well-paid job, book a one-on-one call with me. Link is in the description. You find that there can be some things that can be added to this. Are you getting the process that I'm trying to tell?
Hey, Vamsi, I have one doubt.
Yeah.
Yeah, so Vamsi, so you're like, let's say we are, right now UDP or TCP, like it takes care. I mean, the TID is getting passed directly to those lower level protocols. But let's say you're doing it on, bare metal or UART or some, like you said, like different transfer interfaces. So as per the RF, like, I mean, I'm not trying to equate the RFC to that scenarios where we are sending through UART or something, but I'm just saying, like, based on the RFC, what we see is PID, it is take the UDP takes it as an argument. So, but ultimately TID has to be sent to the through the wire interface, right? Let's say we are taking UART or something. So, but it's not part of the packet structure. So how do we send it?
Yeah, that is where I'm saying you have to create that's what actually I'm trying to nudge you people to think beyond the TFTP packet. The TFTP packet has to be part of some other packet. So this is where I'm saying that if you remove UDP, you will somehow end up into some structure that you have to maintain, that you put it on your UART, that you put it on your I2C bus. So there is some more encapsulation that comes into the picture. If you see the RFC where the in the appendix, the first diagram says list of all the headers, right? The particular physical header, then UDP or TCP header, then TFTP header. All the headers are mentioned, right? So below your TFTP, you should still have certain header that you want to add, which will take these particular TIDs and will isolate the different files that are being transferred. And that's what I'm saying. In one way, I'm saying that if you write this code where you do some encapsulation of the TFTP packet into another packet, you are effectively understanding that, okay, UDP also will be like this. And tomorrow when you look at the UDP code and you remove all the extra error checks or other mechanisms that might be making UDP heavy, the core of the UDP will be similar to what you are going to implement in case if you want to do a bare metal programming kind of thing. Are you getting what I'm trying to say? Otherwise, there is no way you can actually tear down some layers and really understand the software. It only comes through practice and very systematically trying to see which portion of the code that I want to understand first. Then I want to, and which portion of the code I want to assume that is already working for me. So you slowly get into the part of the code which you feel that, which you take for granted as working, and trying to understand in an incremental fashion, how is it working? Getting the point? And for that, you need to slice your packet into different segments and see where each one is sitting and how it has to be done. And this calls for a little bit of implementation. And the reason why I am upfront suggesting STM kind of thing is Arduino is too much abstracted. STM is also a bit abstracted, but you have a appropriate HAL calls to take care of such particular hardware peripheral, but not so much abstracted that you don't have to implement this kind of encapsulation for the complete TFTP packet. Getting the point? Making sense? If you are silent, I am unable to understand.
So one doubt is that here we check it via, so whenever we transmit data here, we are checking it via client and server. We are checking outputs or files of the data to check. In STM, if we implement it, how do you suggest we check out whether how it is working or output?
Print it on a console, no?
So
See, the thing is, first you send from the receiver, or it is like a thing like, I would say, hardcode the receiver side only. Hardcode the receiver side, when I say, assume that the receiver has already sent the packet and it came to your server. So the complete packet is in the memory. Now invoke your server code that you have written on that particular packet and start printing. Now, when you want to send it to the outside, you can put it on the bus and see it. But who is stopping you to put a print statement and print it on the console only?
Yes.
You are getting the point?
Yes.
Yeah. See, when the STM board is connected and it is sending something, definitely on your hyper terminal or something, you can definitely see it, right? Even otherwise, you can actually put prints in the thing and you can see the print statements in the IDE. Did you get the point?
Yes, yes.
Yes. So let us now go for today's session. How many of you saw the, what is this? How many of you saw the document, today's document? Got time to look at and understand what it is doing? Or what is it all about? Anyone? No? No one? Yes, no? Vamsi, don't ask any questions. Just say, finish your job, share us the recording. Our life will magically change. Our knowledge will automatically increase. I just have to say, Khulja Sim Sim. Gone through the last one. Okay, seeing it now. Okay, Lila Prasad, did you see the document?
No, sir. I also have seen the last one. Today I don't have it.
Okay. Anand. Did you see? Chandrika, Snehal, Nikhil, Anirudh? No. Okay. So let us see what the document has. So is the screen visible?
Yes.
Okay. So it's an increment for the previous aspect, I mean, previous implementation, where we are just receiving the read request. And now assuming that the file is present at the server. So first thing is we have to take care of error condition. So the reason why I'm stressing now where error condition is, think of the test-driven development. We want to start with a case where there is no file, right? Getting the point? We want to start with a case where the file requested by the receiver or the client is not there at the server side, which brings us to the first function, which is send error. How it is implemented is secondary, but I want you to understand the fact that if I start with the failure case of the client request, where the client is requesting, can you send me the file? And the server is saying that, no, I don't have the file or file not found. Here the code is handling only one error code, but we have seen in the specification in the RFC that there are more error codes. The point is this function existence or the way this function is coming is directly from. If you want to work with me personally, where I guarantee to work with you until you secure a well-paid job, book a one-on-one call with me. Link is in the description. Understanding of our TDD and handling the error case. So this function we have written. Now we want to understand if at all I have to handle read request, assuming that the file is there. But since I have written this function saying that if there is no file, then I have to send an error. But where should I send an error? I should send the error situation right at the beginning, because I am trying to read the file name which the client has requested. It is not there. So immediately I have to send the error string saying that file is not found and return. Is this making clear? I'm trying to associate or relate TDD now. Now the positive case. We make it work now. Now what is that we make it work? We make that scenario work when the file is already existing. So we start here. Now remember, this is read request. So the moment I ask, can you send me that file? I start with the first block. And I go till the number of blocks that are there.
and I need to have a buffer. Every time I need to send those many number of bytes, which is equivalent to the buffer. Now, if you see the buffer size, 516. Can anyone say why it is 516 and not 512 only?
Because the 4 bytes are for the header.
Perfect. The 4 bytes are for the TFTP header. So the remaining is the block size. Now these are the two things I want you to understand. These two lines and their significance, we will jump to that and then we will come back again here. And that magic is done by select system call. Very popular interview question. How the questions will be asked, where all it is valid, why it is valid. If you appear for companies which are into networking domain, this is a favorite question, like what is select system call? I don't know the history as to why it is called select. Like when people were writing Unix kernel and it was getting developed in university and students were writing pieces of code using C language. And when in Berkeley, when the sockets were being designed, people started giving their own names, which have become now widely prevalent. They would have thought about the select system call in such a way that out of so many things, I am literally selecting one. The proper verb as per the English language, I am literally selecting one of the things. What we are selecting is what we need to understand. So select is a system call which is predominantly used in networking applications. The reason is because a server can have multiple clients. In our case, we understand that each of the transactions that are running between one server and multiple clients also can be easily understood because the instances of communication using TIDs, which is logically pointing towards the direction that a server can have multiple clients. Now, when the server is having multiple clients, it means the server is closely observing those many number of sockets. How is the client connected to the server? Through a socket. Yes. So effectively from the server code, what goes out of the socket is immaterial. Immaterial in the sense, once it went out, it went out. I can only understand whether it has gone, it has not reached and all those things only when the receiver sent something or when my timer elapsed. It is like I say that I am traveling today to my hometown and I take the bus. I will call to my house and say that the bus has come. I boarded the bus and I go to sleep. The only again indication will be given by me that I have reached safely is after reaching my hometown. So if I am not, if the prescribed time after which in my house when they think that, okay, this person would have reached, why is he not calling? Internally their timeout happens, right? That 8-hour period or 9-hour clock, hours or 10 hours gets overflown and they will ask. The timeout happens and they will call or I will call after that and they will, some reason will be there. Simple communication that happening between two people can happen. But socket FDs, I mean, this select system call is concerned only with the sockets. For that, what it has are 3 kinds of socket file descriptors it will keep monitoring. One is the read file descriptors. Another one could be the write file descriptors. And there is third category called exception file descriptors. So the macro, you need to look at really this FD set, file descriptor set. So what is essentially happening is I am collecting all the read file descriptors and I am storing it in something called as FD set. The mathematical term of set, right? Collection of objects. Right? Like that, there will be write file descriptors, there will be read file descriptors. The moment the server calls the select system call, whichever is the highest file descriptor plus 1 will be as the first parameter. The second parameter will the list of or the set of read file descriptors. The third parameter will be the set of write file descriptors. Fourth would be the exception file descriptors, and last would be the timeout value. Now, what is the timeout value? Server is monitoring, or server will start taking action when one of the file descriptors says that I received something. Somebody wrote into me, somebody like some IO operation happens on some socket. Then the server wakes up in the sense it goes and attends to that socket, that particular file descriptor, which is signifying one of the sockets to which a client is connected. Is this clear till now? I'm trying to explain the select system call because it's one of the most popular thing that many people will not understand, and they end up spoiling it in interviews and many other places. The usage is very simple. First, you have to create FD set. Then you have to initialize those. Then you have to set into read FDs or write FDs or exception FDs your socket file descriptor. See, you would be getting one socket file descriptor, right? See this function. To handle RRQ, I got one file descriptor. Socket descriptor. That socket descriptor, because it is coming from client and I want to read it, I am setting into the read file descriptor set. Then I start a timer with a timeout value of, I think I have set 3 or 5. 3. So till 3 seconds or 3, whatever that milliseconds or something, if I don't see a transaction, then I time out. Making sense? Any doubts here? I would like to stop and ask here. If it is not clear, I would try my level best to bring some example from real life, and I will try to explain. Your doubts?
I didn't get the point up till now.
Okay, which is the point did you not get?
How is select being used here?
Okay, let us take this example. There is a server and it can have multiple clients. I told, forget about the clients, but for a server, it is all about so many socket descriptors present, right? It has so many connections. Each connection is signified by one socket. There will be some sockets where I want to read. There will be some socket descriptor where I want to write. There will be some sockets where I will do both read and write. Ideally, the third category is what is more prevalent. There is a socket descriptor connected to a client. From the client, I will read something, I can write something. Yes. Now, because the IO operation, whenever the IO operations happens on a client, then I will go and do the action. Because the server needs to know that which is the socket descriptor on which the IO transaction happened, so that it will go and attend that. Think like as an interrupt service routine here. Select system call, for the first time I understood, I was also struggling. I mentally thought it is like an interrupt call, that when the hardware says to the controller saying that your time has come for taking care of me, then the controller actually goes and takes care of it. In the same way here, the socket descriptor which you have given in the read FDs, when a particular IO transaction happens, then the server go and do the particular operation from that socket. And that is when the select system call returns a positive value. To set up the select system call, what you need is you should first create the set of file descriptors. So this is a generic structure. You can create variables. The standard notation is read FDs, write FDs, and exception FDs. Here we have taken write file descriptors. all these file descriptors should be first set to 0. Initialize. Like how a driver starts, it initializes everything, right? Before the interrupt happens, all my buffers, all my flags, and all those things, whatever are needed, I set it to a known stage or at 0 state. Then I set into these read file descriptors, which my select system call is now going to monitor. I insert my socket descriptor into that because I have my own socket, right? Then I give a timeout value because I cannot keep on indefinitely wait for IO operation to be happening on a particular socket. After some time, it should time out. So I give the timeout value. In case a transaction happens, an IO operation happens on the read file descriptor, the select system call wakes up in the sense it goes and reads that particular read file descriptor, whichever is the socket FD. In this file descriptor, there are a list of so many sockets, right? Typically, it might be reading one after the another. In our case, it is only one socket, which is the client socket.
What do you mean by there will be lots of sockets?
Yeah, you can add. You can FD set socket FD1, socket FD2, socket FD3. Not every client might be ready to send, right? So whenever an IO transaction happens on one socket, it goes and reads that, and then it does the operation. See, think of so many interrupts. The processor might be having interrupts from this sensor, that sensor, and multiple sensors, but not every sensor needs to be attended then and there. Some sensors might be still computing something at their local and then giving an value. So select is similar to an ISR. Okay. Once that particular socket has a transaction on it, in the sense there is an IO operation, I read from that. This is a standard call, receive from. From which address, how much is the length that I got, where is that I am storing, how much I am storing, and where is that I am storing, and from which socket descriptor am I reading it. And this complete operation, after this, I am actually also acknowledging back. Acknowledgement and the block number. This is just an OR operation, right? I am just taking the MSB. Then I break. When I get the correct ACK received, then I break. Else, timeout, retransmitting block. And I am increasing the attempt or incrementing the attempt because I am going to give up this complete operation if there is a failure after 5 attempts. There is a cap on the amount of times that I go for attempts, and there is also,
if you want to work with me personally, where I guarantee to work with you until you secure a well-paid job, book a one-on-one call with me. Link is in the description.
a restriction with respect to after what amount of time I should declare a timeout. So every time there is a timeout, I am increasing the attempts. And if the attempt is failed to receive the ACK for block, giving up, close, return, block plus plus. Now block plus plus is definitely the positive case because everywhere if you see there is an error, we are actually returning, we are not doing anything. So if everything is positively flowing, then one by one block gets incremented. Clear? Any questions? Simple code. This is simple code only. Yeah.
Vamsi, for the timeout, so can you explain the the purpose of timeout? Like, is it like the sock? Let's say that particular socket gets timed out, so it will be expired, or will it be freed or something like that?
No, there is nothing like freed. When you say FD set and you FD set into a socket FDs, that will be there. It is when I say the timeout, it is the time that the server will be spending on that socket, seeing that if there is any transaction. If there is no transaction and the timeout happens, it goes to the other socket FD.
Okay, so let me know if I'm understanding it right. Like, so let's say timeout is given as 3 seconds. So it will wait on that socket. It will wait for that 3 seconds and then move on to the next socket. Is it like that?
Yeah, you can think similar to polling. That is why I don't want to give so many perspectives, like think like an ISR or think like a polling. But the point is the server spends certain amount of time on a socket to see if there is an IO transaction, IO operation happening. If that is not happening, it goes to the other socket. Yeah, because the server has so many clients to take care. Yeah, the simple example, I don't know if you have experienced it. Back in the days when I was very small, and there used to be this summers are famous for power cuts. So all the kids used to play, and then the elders in the house used to bring one big bowl of rice or something, whatever the food, the dinner, and we all used to sit in a circle or arc. So they make one, what do you call, some mouthful, and they put in our hand. One by one, they keep on putting. By the time the first person consumes the food, again they come and they give. So it's kind of polling. How many of you enjoyed or experienced these kind of things? That you are playing all through the evening, power cut happens. None of you? Yeah, Chiranjeevi says yes, Ananda, kind of. Yeah, the good olden days, huh? So at that point of time, the elder person giving us the food actually is implementing or was implementing the select call. Yeah.
So I had a question. So the current code that you have provided, is it able, so from the looks of it, it should be able to process that if we run the multiple clients on one side and we queue for multiple files, so it should be able to handle that.
See,
right?
the internal implementation, whether it is a queue or something, I am not, but what I can say is, if you have multiple clients, because for every client, okay, let me show now the code where this handle RRQ comes. Then it becomes more evident because it all comes from the main function, right? So let's go to the handle RRR function, which is being called in main. Let us come to main. These are all standard and all those things, setting up the socket and everything. I'm creating the socket here. I am creating only one socket here. And in the handle receive from, yeah, in the handle RRQ, the moment I see that the opcode is read request, I am passing one socket FD, only one. Here, if you send multiple, they all will be made part of this FD structure. Internally, how the server takes care, or the OS, see, essentially, select is a system call on top of some OS functionality, right?
Yeah.
Internally, how it implements, we don't know. But to precisely answer your question, if you populate your socket FDs into this structure, the maximum number that it can hold, those many clients your server can comfortably handle.
One more thing I think it should require is the number of sockets our server file should need to open, or is it fine with one socket? Because in our code, it just opens the one socket. So I don't think it will be able to.
Yeah, this is only a boilerplate kind of code.
Yeah, it's just, I'm just discussing it to get the concepts clear.
You can go for multiple sockets.
Yeah, okay.
Yeah.
So again, a related question, but how does a server handles so many multiple sockets if it doesn't know, like for example, if it doesn't open the socket, I cannot create a connection with the server, right?
Yeah,
So how does it?
if the socket fails, socket creation failed, exit failure.
Yeah, so basically, what I'm asking is that, for example, we are 11 students and 11 clients, and you are the server, right? So you need to open 11 different sockets to handle the queries of 11 clients, right?
Yes, that is true.
Yeah. So how would you know to open the 11 sockets? So for example, you don't know how many students are like how many clients you are going to connect with. So by beforehand, how would you know to create enough sockets to handle all of the?
Okay. I have an accept call, right? See, when in the fundamentals of socket programming, it is always the accept call. I accept a connection, then I fork one more socket and I attach it to the client. See, unless
Got
the
it.
client doesn't make a call to saying that I want to connect with you and I don't accept, I will not be creating a sock structure, right? Yeah, I will not keep. Okay, there are also scenarios. It all depends on use case. There may be a scenario wherein the server will say that I will create these many sockets and I will put it as a standby. And whenever a client comes, I will assign one socket to it. Right? See,
Yep.
ultimately, if you see socket, the socket call also at the end, somewhere it has to get into the device driver part only and send it outside. These are all abstractions provided by the operating system to handle the complexities of the product requirement or the challenges that are thrown in the real life. And yes, socket accept call is the one which creates those many number of sockets.
Answered.
Yeah. Yes. Any question in this? Any doubt in this? This is very straight through. Yeah. There is one more thing, which is acknowledgement. But there are some slight points in the small points in this code that I would like to highlight. If you people would have observed, somewhere this is error. Okay, leave it. Yeah. Why do you think it is buffer plus 4?
It is skipping the header.
Again, the 4 bytes for the TCP header. After the TCP header, I am having the actual data. And recollect the what is that? Packet format that we are sending. First byte is 0. Second is opcode. And from here, the block number. Block buffer 0, buffer 1, buffer 2, buffer 3. The 4 bytes have to be filled, right? After the 4 bytes, the actual data. And that is where if you see here, buffer 3. And if you see somewhere here, the data would be somewhere buffer plus 4. Items. Add buffer received from acknowledgement. Where is that code? Yeah, here. N plus 4. Clear? The total number of bytes are n plus 4 because 4 are already filled. And if it is an acknowledgement, very simple. I got an acknowledgement and I am checking whether the block has been reached or not. So correct acknowledgement received. Because the onus is on the server only to receive the acknowledgement and ensure that the packet has been successfully delivered, right? So the client would have sent the acknowledgement. So I will check whether it is acknowledgement and whether the whether the value in this is actually the block. Where somewhere here I will have the block. Yeah. Block 1. Now when the successful transfer happens, at the end, block plus plus. So at any point of time when I have to when I receive the acknowledgement, my block would have been already the block that I would have already sent. Clear? Clear? Confusing?
uh,
क्या हो रहा है?
I have one question. So, what is that select doing that we can't do it with our previous code or already existing functions? That is one question.
Sorry?
What is what is so special, or what is select doing that we can't do without with our previous functions? It is doing something different that we cannot do with the existing or like the functions which we didn't use.
Correct. If you know that there is one client, if it is simple TX, RX, UART, send, receive, fine. But if it is I2C where you have a master and slave, you need to have addresses, mechanism, and some packet format, right? That the last
Yes.
bit is read or write.
Yes, yes.
Yes. That's why I'm telling select is a kind of polling stuff only. That you have so many people that you have to go and do it. If you have only one person and you know you are communicating with them, you don't need that. Yeah.
Like, what are the consequences if we don't use select? Are there any?
There are no consequences. It's your use case where you are saying that I have only one client.
Oh.
Yeah, there aren't any consequences. Your need dictates whether you should use select system call or not. Hello, is it clear?
Yes, yes. Sir, and the 4 n plus 4, right? That when we say what does the 4 include? Like OP code is 2, and
Which is the line you are talking about? Line in the sense, can you spell out the line you are talking about? Send to?
no, that n plus 4. You are asking that 516, 516, and 512. The difference.
Yeah, that's where exactly. See, the standard block size is 512, but you have 4 bytes of TCP header, right? That's why the buffer size has to be 5 to 516. Is it clear, Harsha?
You mean it's not the header that we saw, right? For the data, like OP code is 2 bytes, not that.
If you want to work with me personally, where I guarantee to work with you until you secure a well paid job, book a one on one call with me. Link is in the description.
No, that is the header, right? That is where the header is.
So my question is, what about the file name and mode, those kind of things?
File name.
And they won't take 1 byte, right? They won't take 1 byte. They'll be larger than 1 byte. Or I might be confusing with other things.
No, I got your point. I understood your confusion also. See, this function is handling the read request. Handling the read request, which means already you got the file name. The server would have already sent the file name.
Yes.
You are opening that file. After that, when you are sending the data, which is one block, what you need is only 416 bytes. Because you already got the file name, right? You already know whether the file is there or not.
Yes.
So if you come here in the main, bind socket and all those things, here I am reading the opcode. So the client is saying that I am doing a read request. Now extract the file name here. This is a character pointer only, right? This is your local memory. Is your doubt clarified now?
No.
I know where you are stuck. But I
Yes,
want you to clearly observe this and understand what is happening here. Client has already sent the file name. I want text1.c. I am already holding it in this pointer, right?
yes.
It is there. Whatever is the buffer plus 2 that I am having, that file name, that I am sending it here to the handle RRQ. What is the memory, that 516 that is there, that is for sending from my side that block of data. I already have that file name. I know this is the file. In that file, 512 bytes plus 4 bytes of TCP header is what I am sending. You are getting confused between that 516 bytes and trying to relate, oh, where is the file name? File name can't be so much. It can be anything. I can't decide upfront, right?
Yes, yes.
See, you need to understand the transaction, how it is happening. Server is there, client already sent, this is the file name I want to get. That is when the server is saying, okay, I got your file name. Let me handle your read request. Then in the read request, it is trying to open the file name that it has sent. Clear?
Yes, yes.
This is a handle RRQ function. It will not take care of file name and all those things. Already the server, the main function would have to handle the file name and every stuff. Yeah?
Yes, but
Hey, Vamsi,
Uh,
can you once again go to that one? Can you go to the main function?
what is the main function?
Yeah.
This is the main function. I am in while one, waiting for
Okay.
RRQ.
I'm unable to see your screen.
This is the main. Int main.
Yeah. So okay. In main, right? So you said so, right? Like so since this is UDP, we don't explicit accept, right? So is it internally for every new connection it will fork? I mean, how is it like, for new connection? You said something that I couldn't catch that properly. So let's say one client is there. So this is all happening, but let's say I have simultaneous clients coming back to that. So how is it handling that? Can you just reiterate on that concept?
Yeah, those things will come.
If you want to work with me personally, where I guarantee to work with you until you secure a well paid job, book a one on one call with me. Link is in the description.
At the later point of time. Fork and multi-thread, everything will come at the later point of time. But ideally, I gave a picture that there will be a socket which listens and accept the connection, and then one socket, there will be another thing that socket forks and it will give me a moment. I will show you if I can get that file. And this is for people who wants to if I get that PDF, then nothing like that. Yeah, I think I got it. Yeah, in the meantime, any other question, I think that is getting downloaded.
Just one more, Vamsi. So I mean, just since you brought fork up also, so I was going. I mean, fork. Let's say, can we use fork? I mean, can we make the program such a way that we can do this? Multiple instead of using select, can we go through the process of fork? I mean, can that be an alternative?
Can you repeat? I did not get your question.
No. So we are here. Let's say server point of view in the handle RRQ. That function you use the select function. Okay, that is basically I'm trying to handle different socket keys. That is basically multiple clients. You're trying to poll fixed amount of time. Split between multiple sockets. Let's say handling multiple connections. Great. So let's say we hold it on one side. Let's say we write a program in a totally different way where we are handling all these things through fork. I mean, let's say we're forking it when a new connection comes and handle that client separately, independently. So is that also a valid way of doing instead of using select? Because select we are using to switch between different basically clients, right? Like we are trying to poll different clients sockets. So fork, if we do fork, then we don't need to use any select, right? We can just directly focus on the socket. I mean, it may not be the efficient way. I'm just asking from conceptually, is it valid?
It is valid. From the way that you are thinking, I don't see any issue with that.
Okay.
Yeah. See, but one server instance, if it has to handle multiple transactions from the same client also, okay, your point is also valid that if I have multiple servers where I am forking and all those things, then I don't need a select system call. Yeah, possible.
Sure.
Possible.
Sir, so while doing that, are we using the same port or
Harsha,
or
is this with me only that I'm not able to hear his voice?
or is it just low by default?
It's clear to me.
It is clear to you?
Yeah.
Hello, now
Okay.
can you hear me?
I
Harsha,
can hear you, Arisha, but
is it feeble or is it loud enough?
it's a little bit feeble, but it's clear.
Yeah, Harsha, can you please ask?
So when we do the fork process, we have to use different ports, right? Port number should be different for each process. When you do the
Fork?
forking, yes.
No, fork has nothing to do with port numbers and all those things.
Yeah.
Fork has nothing to do with port numbers and all those things.
So what happened was when I was running the first code, when we had client and server code, first code. So each time I ran the client code, and what I used to do was on the server side is to print the port number also. So every time I ran the client code, I used to get a different port number printed.
Port number for what?
Port number for the client. So
Okay,
here
can you
we
send
are.
me that code, whatever you are saying? Port number for client, I'm not able to relate, like, what is that port number, port number for client?
Sir, we are not. So for server side, we are using 8080 as the port now, fixed. For client, we are not using any port like that, so it will randomly assign some port for the communication.
Yeah, I think the connection, the end connection of the client, maybe it is randomly generating and assigning the server, the client side, some random stuff.
Okay.
See, port essentially from every application, you can think of your port number as an application, okay, like 433 for HTTPS and all those things. Now, when you don't define a particular port number, then, but there has to be an endpoint which has to be uniquely identified on the other end. So for every instance, I do a random generator and I get some port number. But one thing is very sure that all the numbers that you are getting will be below 650, 65536. So let me show you, maybe with this diagram, if the things will be little bit clear. See, there is a client socket and there is a server socket. So the client socket now binds to the server and a port is bounded and the server is now listening. So the client says that I want to establish a connection. So what the accepted server is saying that it will create a new socket internally and bind it to the client. So that when there is another client that requests, then it creates another instance of it and it will start binding it to that client.
If you want to work with me personally, where I guarantee to work with you until you secure a well paid job, book a one on one call with me. Link is in the description.
This is how typically the servers operate.
Okay.
Yeah.
Yes. Yes. Yeah.
Vamsi, just a small extended doubt on that. So let's say we are, I mean, this is regarding that forking thing. So let's say we are doing forking, so basic client server. I mean, not talking specifically about TFTP. So if multiple clients are coming, so anyways, the server is initially listening on 69, right? Let's say for TFTP, for example, I'm coming back to. So when you fork it, then it will again, so do we get, will be there some conflict with ports? Like 60, let's say the new fork process will also.
No, there is only
Um,
one person listening, right? There is only one person listening.
okay.
See, when you do a fork, the child will be an exact replica of the parent, except for its socket ID. I mean, except for its PID, process ID. Rest all things are same. If you recollect the fork basics, it will be a replica of the parent except for the process ID. And that's why that's why the server catches the child ID to understand what is my child. Yeah.
Okay.
Yeah. And the fork call also gets executed in the child and you get a 0. So this is a good book about Bluetooth essential for programmers. So anyone interested in understanding about Bluetooth programming on Linux, this is a very good book. So if you want, let me know. I can share that book to you. Anyone want that book?
Yes,
Yeah.
sir, please share.
Sure, I will share. So any other question?
Vamsi, like share the recording, Vamsi. I need to go to recording, so I need to come
Yeah,
again from
recordings
there
are
first.
being shared the next day only, right? Next day morning, I am putting
Yeah,
the
yeah, yeah,
recording.
yeah, Vamsi. Yeah, because like
See,
I will again listen the recording actually. Yeah.
no,
Forking and all is first time I'm
as long
listening,
as you are
Vamsi.
not hitting the code, it will be confusing only. You have to hit the code.
Yeah. Forking, first time I'm listening that word forking actually. Yeah. I have not go listen that word actually.
No, this is not right, Chiranjeevi. Because I was telling from the beginning that look at that IPC from B's. I almost told, I don't know, 8 to 9 times. Every time I was saying download this, I was saying bees dot some link and all those things, download and read that. Yeah, that's very important. You need to understand these things. If there are no questions, we will conclude the call. Start looking at the code, execute in small pieces. The intention of giving you incremental code is to enable you that you will actually adopt the TDD. You will refine your essay. You will come up with the diagrams. Get to the pseudocode. I want you people to take the code and reverse engineer and see the whole process happening, or whole the stack of learning that you start at requirements and finally it boiling down to the code. If you have not traveled that path, at least from code you do a reverse thing and you understand. Yeah. And please be active on LinkedIn. Start tagging me, comment on others' posts. Yeah, and Swami, thank you for putting that point in the group. That if you have a post then about what is happening, your GitHub thing and all those things. Yeah. No more questions.
Sir,
So can
I
we
want to read
have
up on
I had a
selector. Do you suggest anything on select?
suggest
Any resource on select? Or is it in Beige networking guide itself? There is section on select.
was that gave me job in Cisco, those 2 documents.
Okay.
The time when I was saying that what is this Greek and Latin, I'm not able to understand anything. When I was struggling in Bosch and I got an interview call from Cisco, I read these 2 documents only and I went. I did not think of any other thing.
Okay,
Yeah.
Vamsi, then we too will see that, yeah. We'll read
Yeah,
the document.
it's a excellent thing. That person has written, and he is there on LinkedIn. I tagged him twice or thrice, and he responded on my post also that I have learned from here. Yeah, you should actually go and observe his thing. And there is one more book for people who wants to have that funny side of things of software and all those things. There is one. First, you need to actually go and subscribe to the newsletter called Embedded Muse. How many of you know this gentleman by name Jack Ganzel? Heard his name, Jack Ganzel?
Yeah, yeah, yeah.
Yeah. You go to embedded.com. There are these people you need to actually follow and read whatever they have written. Jack Ganzel, Dan Sachs. They write so well. And Jack Ganzel has written the art of programming embedded system, the art of designing embedded systems, and his newsletter is Embedded Muse. You go to his website, you will find all the previous editions of his whatever this newsletter or whatever, and his articles on embedded.com. You will get a lot of understanding. Great. So if you can be on camera, I would like to take a snap.
One question I had before we close. You talked about the kernel 1.0 overview lectures. Would it be possible to plan it or like after whether we are going to do this after this series, or is there anything else on your mind regarding that?
See, let me stop recording. I don't know how to stop recording now. Yeah, I can.
If you want to work with me personally, where I guarantee to work with you until you secure a well paid job, book a one on one call with me. Link is in the description.